In this video, I'm going to be giving more partial fraction decomposition examples, and then in particular we're going to be talking about examples where there are repeated linear factors in the denominator. Okay, so this is a repeated linear factor in that it's showing up twice because it's squared, okay? So this one's only once, this is not repeated, but this one is repeated. Alright, so then when I do my decomposition, I'll have a over x plus 1, okay, and that's, you know, same as in the previous video, nothing different there. But now I need to take into consideration this guy, so how am I going to do that? So then I'll have plus b over x minus 2, and then I'll have plus c over x minus 2 squared. Okay, so you know, if it was the third term, if this was to the third power, then I would have plus d over x minus 2 to the third, right? So you just keep on going until you reach its power. So this 1, 2, if there was a third, you'd have a 3, okay? So that's the way you decompose when a factor is being repeated. Okay, so this is the decomposition for that guy. All right, first step to doing this is going to be the same as in the previous video, which is to multiply both sides by x plus 1, x minus 2 squared. Okay, so that way on the left-hand side, these will cancel. Okay, so on the left-hand side, I'll just have 3x minus 7. On the right-hand side, I'll have a, and then the x plus 1 will cancel, so I'll be left with x minus 2 squared. And I'll have b, and then the x plus 1 won't cancel, and one of the x minuses 2's will cancel. Okay, so instead of it being squared, it'll just be x minus 2. And then plus c, and then the x minus 2 squared will cancel, so then I'll be left with x plus 1. Okay, so let's see. So the first step I'm going to do is I'm going to plug in negative 1, and that should help me find what a is, right? If I plug in negative 1, this one will cancel, and this one will cancel. So that'll tell me what a is. So I'm going to go ahead and do that. Plug in x equals negative 1. So then I'll be having 3 times negative 1 minus 7 equals a times negative 1 minus 2 squared. Okay, and then b and c are gone because they have x plus 1 in their term. So the negative 1 makes that a 0. Okay, so then I'll have negative 3 minus 7 equals a. Negative 1 minus 2 is negative 3, and that's squared. So this would be negative 10 equals 9 times a, and then divide both sides by 9, so I'll have negative 10 ninths equals a. All right, let's see, is there anything else? Can I find anything else by plugging in? Well, if I plug in positive 2, can't find b, right, if I plug in positive 2, but I would be able to find c, right? If I plug in positive 2 minus 2 is 0, this is 0, so those two would cancel. So let's go ahead and do that. I'm going to go ahead and plug in x equals positive 2. So then I'll have 3 times 2 minus 7 equals, the a term and the b term cancel, so that's c, 2 plus 1. 6 minus 7 equals c times 3. Negative 1 equals 3c. Divide both sides by 3. Negative 1 third equals c. Okay, so now I haven't found b, right? And so there's two ways you can go about finding b. We talked about in the first video another way instead of plugging in like this. First off, there's nothing I can plug in to get b like directly, just like how I did these ones, right? But one way I could find b is to distribute, everything, combine like terms, and then compare it to what I see over here, and then write a system of equations and solve. We kind of talked about that in the beginning on the first video for partial fraction decomposition with distinct linear factors. We talked about how to do that. The other way that we could do it is, well, if we have a and we have c, then I can just plug in anything for x, and it should lead me to what b is. So that's the easier route, so that's what I'm going to do. So, you know, I can just plug in any convenient number for x and then plug in what I know a and c are. So, I know a is negative 10 ninths, c is negative 1/3. So just plug in any convenient number for x. So I'll just do 0, okay? So then I'll have 3 times 0 minus 7 equals negative 10 ninths. 0 minus 2 squared plus, b is the one thing I don't know, so I leave that in there. And then 0 plus 1, 0 minus 2, and then plus, or actually minus, let's see, minus 1/3 times x plus 1. Oh, not x, but 0. 0 plus 1. Okay, so this cancels, and that becomes negative 7 equals negative 10 ninths. 0 minus 2 is negative 2, and then if you were to square that, that'd be 4. Okay, plus b, this is 1, and this is negative 2. 1 times negative 2 is just negative 2, so I'll just write that minus 2b. Minus 2b, minus, and then 0 plus 1 is just 1, so minus 1/3. Okay. Let's see, I will have negative 40 ninths. I'm going to move the 1/3 around, so I'm going to put that first. So I'm going to have 1/3, which is the same as 3 ninths, and minus 2b equals negative 7. Okay, so that'll be negative 43 ninths minus 2b minus 7. Okay, let's bring the negative 43 ninths over by adding it to both sides. So let's see, 7 times 9 is 63, so this will be negative 63 ninths, which that's 7. I just put a 9 on the bottom, so we'll have the same denominator, plus 43 over 9. Alright, that equals negative 2b. Okay, then that's negative 20 ninths equals negative 2b. If I divide both sides by negative 2, I would have, so 20 divided by 2 is 10, so 10 ninths equals b. Okay, so now I need to write my answer. I have a, b, and c, so I would have negative 10 ninths divided by x plus 1, but you shouldn't have a fraction on top of a fraction like that, so you shouldn't write it like that. Instead, you should write the negative 10 on the top. Oh, let me erase that. So I have negative 10 on top, and then the 9 is on the bottom, okay? And then plus b, which is 10 ninths, so that 10 on the bottom, 9 on the, or 10 on the top, 9 on the bottom, then x minus 2. And then c, which is negative 1/3, so that should be minus 1 over 3 times x minus 2 squared. Okay, and that is the decomposition. You know, you can always check your decomposition answers by, well, adding these together and then checking that it equals this. Okay, let's do one more example. Alright, so in this example I have, you know, it's this factor is being repeated 3 times. So first step is to write this as a over x minus 1 plus b over x minus 1 squared plus c over x minus 1 cubed. Alright, now once you've done that, multiply everything by x minus 1 cubed. So then you'll end up having, on the left hand side, you'll just have 5x. On the right hand side you'll have a. One of the x minus 1s will cancel, so you have x minus 1 squared. And then over here, 2 of them will cancel, so you just have 1 left. And then on the last, none of them will, all of them will cancel, so you just have c. Okay, we can find c by plugging in. If you plug in x equals 1, you can find c because the 1 minus 1 will cancel. So you'll have 5 times 1 equals c, so 5 equals c. Okay, so now how are you going to solve for a and b? The only way you can really solve for a and b is to set up a system of linear equations. So let's go ahead and get started with that. So to do that, I'll have 5x, so I need to distribute these ones. So I'll have a times, well, let's do x minus 1 squared. So that would be x squared minus 2x plus 1 plus b, I'm going to distribute that b, okay, and then plus c. So this would be ax squared minus 2ax plus a plus bx minus b plus c. Okay, so let's combine like terms. So the only thing with an x squared is a, so that one's gone. And then with x, we have, so plus negative 2a and a plus b, and those are both being multiplied by x, so that's this one and that one. And then for the constant, I have a minus b plus c, okay? Alright, so that equals 5x. Now, if I compare the right and left hand side, I don't see any x squared over here, so a must equal 0. And on the over here, I see 5. This must equal 5 because it's times x and that's times x. So this negative 2a plus b must equal 5. And then this over here must equal 0 because there's no constant over here. So let's go ahead and set up what I just said. So first a minus b plus c equals 0. And then negative 2a plus b equals 5. And then a equals 0. Okay, so that's my system of linear equations. I already know that c equals 5. Okay, so I can, oh, and I know a equals 0. So with those two pieces of information, I can solve for b pretty quickly. So I'll go ahead and use this equation to solve for b, because, so that'll be negative 2 times 0 plus b equals 5. Okay, that cancels, so b equals 5. Alright, and so I have b equals 5, a equals 0, and c equals 5. Right, so you can see in the first equation that's still held because that'd be 0 minus 5 plus 5, which is equal to 0. So all the equations are being satisfied. Okay, so now I can just write my answer. So a is 0, so the first term basically I don't need to write it, and then the second term, so b over x minus 1 squared, and then the third term is positive 5, so that's plus 5 over x minus 1 cubed. And that is my partial fraction decomposition.